Okay, so now we're going to talk about the inverse normal functionality in your TI-84 calculator. So we use this if we are given the probabilities or the area under the curve and we're looking for k values or what we call quantiles. So I'll use the same problem from last time. So I have the diameters of coffee beans being normally distributed with a mean of 6.1 and a standard deviation of 0.8. So again, the notation has to be written in proper mathematical form. So let's say the variable is x, is normally distributed, and the parameter, the second parameter, needs to be the variance, not the standard deviation. So if Yumi Cafe rejects coffee beans that are either too small or too large in diameter, and it is said that 1.2% of coffee are considered too small, while 3.5% are considered too big, we want to find the smallest diameter of coffee beans accepted in Yumi Cafe. Okay, so we are going to illustrate that normal curve and specify the mean and an indication of the standard deviation and visualize where that 1.2% is. Okay, so perhaps 1.2% is over here. Okay, so that area corresponds to 1.2%, and we call this quantile, let's say A. So notation wise, this means the probability that x is less than a is equal to 1.2%. Okay, so in my calculator, I'm going to write second function vars, which gives me the distribution menu, and I choose option 3 for inverse normal. The area that we will provide, so there are three options. The area that's given to us here is the area on the left, so I'm going to use the left option, and I have to convert this area into a percentage. So I'm going to say 0.012. So we write the mean and the standard deviation. Okay, so we're going to say that's equal to 4.29. Okay, so therefore A is equal to 4.29 centimeters. Oops, millimeters. So that means any coffee bean whose diameter is less than 4.29 millimeters will be considered too small and will be rejected. For question B, if we want to find the largest diameter of coffee beans accepted, we are going to look at 3.5% being considered too big. So that should be on the higher end. So we're going to say that that area is 3.5%. And let's say that is quantile B. Notation wise, I should say the probability of x greater than b is equal to 3.5%. And I'm going to use my calculator to identify the area on the right. So I'm planning to use this option, so I can provide 0.35 or 3.5% as the area specified on the right. Okay, so that will give me a b value of 7.55 millimeters. So again, this means any diameter greater than 7.55 will be considered too big and will be rejected. The last question is find the diameters of coffee beans that are in the middle 40% of all coffee beans. So we could visualize it this way. So in the middle 40%, okay, so the area here is 40%. We could choose variables c and d to represent that. And notation wise, we can say the probability that x is between this c and d is equal to 40%. That is supported by my diagram, but this notation does not necessarily imply that c and d are of equal distance from the mean. Okay, although the diagram should be able to support that. That is what we require. Okay, so we use the last functionality that we have not used, which is center. So we specify the area to be 40%, but we use the option center, meaning the area at the center is 40%, equally symmetrical from the mean, 20% to the left, 20% to the right. Okay, and this is going to provide two numbers which will correspond to my C and my D in my diagram. So C is 5.68 and D is 6.52. Okay, so that means the diameters, the middle 40% of the diameters range from 5.68 to 6.52 millimeters. Okay, so those are the three functionalities if you have the TI-84 plus C or plus CE. But if you have TI-84 plus, it does not have the functionality of choosing whether you are providing the left, the right, or the center area. The default here is it's going to ask for the area from the left only. So for the first question on A, if you send 1.2%, it's going to give you the same answer as this one. So that's default. It's going to ask for area on the left. So for part B, you have to change this area so that it will give the area from the left. So if that's 3.5%, the area from the left should be 96.5%, and that should be the area that you provide in your calculator to give you the same area over here. It's a little bit more complicated if you're looking at the middle. So you have to do this one at a time. To find C, you provide the area on the left, from the left. So if that's 40%, that's 20%. This will have to be 30%. Okay, so actually I could just do this. 30% is 0.3. Okay, so that will be 5.68. That will be your C. To get your D, that's 50, that's 20. D is supposed to be 70% from the left. So that will be 0.7. Okay, and then that should give you the same answer, which is 6.52 millimeters.